Let's design Uber in the next 60 seconds. This video also has notes for your revision and a framework that you can apply to any of your system design interviews. So follow and save this reel for your future interviews. So starting with a basic overview. So Uber is a ride-sharing platform that connects the passengers with the drivers. Now requirements can be of two types: functional requirements and non-functional requirements. Functional requirements defines what the system should perform, and the non-functional requirements defines how the system should perform those functional requirements. For Uber specifically, the functional requirements can be: user should be able to get an estimated fare for their ride, user should be able to request a ride, user should be matched with the most optimal or the nearest driver, the driver should be able to accept a ride request, and the non-functional requirements can be overall low latency in the system, strong consistency in the ride matching service. That is, a single ride should not be accepted by more than one driver. And the system should be able to handle a high throughput, that is a very high number of requests. So a high level design is a very basic design that is able to fulfill all your functional requirements without considering the scale that your system is operating at. And the API design is concerned with the REST or the GraphQL endpoints in the system that either the user will make use of to communicate with the system, or the individual components will make use of to communicate with one another inside of the system. A very important point for the high level design is pick each of the functional requirement one by one and create a very basic design that is able to fulfill that particular requirement. At this point, don't even think about scale. Just keep your interviewer informed that this is the basic design and you will improve upon this later on. And if your interviewer asks you to deep dive on a particular aspect or a particular component of the design, you can also do that. Because at the end of the day, it's our job to make the interviewer happy and give out signals that we are qualified and we know the stuff that we are talking about. Now coming back to Uber, the first functional requirement was rider should be able to get an estimated fare. Over here, the user should be able to get an estimated fare for their ride based on their pickup and the destination. And this is the API endpoint that the user will make use of to get the fare based on the pickup and the destination. This is what the design should look like for this particular requirement. The rider client will make a post request to the API gateway. The API gateway will forward the request to the ride service. The ride service will have the business logic to actually calculate the fare, and the ride service will also make an entry in the database for that particular fare. And once that entry is created, the fare ID will be returned back to the user. Now coming to the second requirement, that is the rider should be able to request a ride based on that estimated fare. Once the user is satisfied by the fare, they should be able to issue a ride request to the system. And this is the endpoint that they will make use of to actually issue a ride request. This will contain a fare ID and it will get back a ride object as a response. For this particular requirement, we have not changed the design of the system. We have just added this ride table to the database. Third requirement, rider should be matched with the most optimal driver. To get the most optimal driver, the system at all points should know the position of all the drivers. And for the same, the driver client will send their latest position to the system at regular intervals using this particular endpoint. And to facilitate the ride matching, we have added the following components to the system. That is the driver client, the location service, and the ride matching service. The driver client is responsible for sending their latest location to the system so that the system can keep this table updated with the latest location of the drivers. And when the rider client issues a ride request, the ride service calls the ride matching service, and the ride matching service get all the nearby driver from the database and matches the drivers with the riders. Now coming to the final requirement, that is the driver should be able to accept or decline the request in a timely manner. So once the ride matching service is able to find out the most optimal driver, a notification is issued to the most optimal driver to either accept or decline the request. And for the same, a notification service is added to on top of already existing system. Now the thing is, the above solution works and more features can be added on top of it, but the solution that we have proposed fails miserably at scale of, let's say, a million users. So in the next part, we will optimize this system for real world scale and also satisfy our non-functional requirements. And at last, follow and comment notes if you want these notes for your reference. And thanks for watching.